we are discussing about aggregate tables. Okay, aggregate tables are something that we will be using to improve our performance. The performance in the sense, let us say we have some data with us, like I'm going to query this employee table. Now I just want some data, like I just need the sum of salaries of each job role. Select sum of sal, comma, job, comma, sum of sal, emp. We need to use group by operation over here. Group by job. Let us check whether this works properly or not. See, now we are grouping this thing. Let me open one more session over here. Okay, this is the data that is available with us, and if we feel like we just need only summarize the data. Okay, summarize the data as per the number of job roles, or maybe okay, department wise role. We don't need it in detail. Here in this detail, in this table, the level of detail is, we have the level of detail up to employee level. But whereas coming to this table, we have the least level of detail is up to job level. Here we have salaries up to salaries. We have the details of salaries up to job level only. But whereas coming to this table, we have data up to each and every individual employee level. Data is available with us over here. In data warehousing, we call this thing as granularity. Granularity is nothing but, okay, this granularity is nothing but least level of detail. We call this term as granularity. But coming to our OBI part, now we are working on something called as aggregate tables. Aggregate tables are something like, here what we have done over here is, from this table we have done some aggregation over here. Yeah, aggregation is nothing but applying some summarized queries like this sum and all. We have done some aggregation over here, and on the top of this table we have done some aggregation, and we made the least level of detail up to job only over here. Okay, if if in our business scenario more number of queries are going to hit, like they are just monitoring all the records on month level, or else if they are going to extract all the reports on some top level, like maybe in month level, maybe in district level, maybe in region level, and they're not very much bothered about the detailed level, that is like a detailed customer level, or detailed sales rep level, or detailed individual level. They just want over the overview. More number of queries are going to hit the overview of regional sales, or maybe the overview of the entire stuff. So if more number of queries are concentrating on that data, and we have a table like this, now what's going to happen in the background is then they are going to hit this table only. Whenever that kind of whenever this kind of summarized queries are going to hit this table, what happens in the background? This whatever the sum operation we have over here, okay, every time this sum operation is going to be performed over here. The sum operation is nothing but here we have only around set of 14 records, but whereas in production environment we will be having around millions of records, and applying a sum operation on millions of records, it means that it's going to affect the performance, because in order to perform this sum operation it's going to take it's going to consume some amount of time over there. As it's going to consume some amount of time over there, it's going to impact the performance. Okay, if we say if you develop a condition kind of thing, like if the data they are requesting is kind of summarized data, then go and hit this particular table. Okay, as we have summarized data over here in this table, it's not going to take much time, and it's going to fetch results very fast. If the data is not summarized and if we need some detailed data, then go and hit this particular table. Okay, the scenario is clear, right? Depending upon the data that is requested, that is requested, okay, we will be depending upon the data requested, we will be selecting the particular table. If you are going to provide such kind of condition to the tool, then the tool can easily understand whether which table it needs to query and extract the results. We need to provide such guidance to the tool. Okay, that is all about the concept of this aggregate tables. Okay, whenever the customer is requesting some aggregated data, then we are going to hit this kind of aggregated data. When the customer is requesting a detailed level, then we will be hitting this detailed level table. Depending upon the type of query, we need to dynamically select which table that is needed to be selected. Okay. That configuration in OBA is called as aggregate tables. Okay. In order to work on these aggregate tables, what I'm going to do is, let me log into Oracle BI server. Okay, I think I have opened it yesterday. I think it may not be working properly. File, click on Open Online. Now I have opened my AppD, and now I have imported I have just right clicked on my connection pool and clicked on import data. Click on next. And from supplier to, for all my dimensions and facts, I do have some aggregate tables. So I have imported the following aggregate tables, that is this D1 order AGG1 as well as this month's D1 product type, one, two, three, and I do have one more thing, that is maybe sales reps, D1 underscore sales reps. Okay, I have imported all these 4 tables. I have already imported them. I just want to show you how I have imported these things. After importing the tables, I have created joins. After importing the tables, I have created joins between those tables. Okay, let me check whether do I have any backup copy of my RPD so that it will be very clear for you to understand all these steps. open offline. Okay, let me open this thing. Here I need some aggregate tables over here. Go to this connection pool, click on import metadata and click on next. And here I will be importing the set of tables. This is D1 order AGG1 and D1 underscore sales rep, as well as this months and D1 underscore product type. Already that was imported, and click on import. Just to keep you remembering, this importing tables won't take much time. If it is taking much time, then it's an indication for us that it's got stuck somewhere. So let's wait for some time, and if it is not, if it is behaving like the same as it is now, then we need to just kill the entire task from task manager. Oh, it's not working fine. Okay, let me kill this task. Start task manager, and here I'm going to end task. And this is not responding. Okay, this is running in some other session. I'm going to end this task as well. Now everything got closed. Let me open this administration tool once again. That used to happen regularly most of the time. Whenever we used to import new tables, we'll be facing these problems. Click on open offline. Okay, I'm just copying this dimension hierarchies and level based measures. I'm pasting it over here. Okay, click on open. Now I want to import new aggregate tables. import metadata. I just want to import the tables itself. I don't want these keys and foreign keys. And in this supplier too, I want to import this D1 AGG1 as well as D1 underscore sales rep as well as this months. Click on import selected. See, now immediately they got imported. And click on finish. Now I have imported this D1 sales rep, this months as well as this D1 order AGG1. And I have already imported one table called as this D1 product type. These are the 4 new tables that I have imported. What is the next job that we need to do after importing tables? Okay, after importing tables from the database, the next immediate task that we need to do in physical layer is we need to create. Okay, we need to guide the tool whether which table is joined to which table. That means we need to provide joins between those tables. Okay, in order to provide joins, just select all the tools, right click on them and select this physical diagram, select objects only. And here using this new join, create join between D1 orders AGG1 and D1 sales rep. Here sales rep is the key and here rep key is the key over here, and from join this AGG1 and months. Here month code is the key over here as well as here period key, PR key is the key over here. And coming to products, here type code as well as type key. Now we have created join successfully. And now the real picture starts over here. Here we have imported new columns, and we already do have some columns that are already present over here in all these columns. Okay, now we need to map these newly imported columns to these columns, but this table is not having any direct join relationship with this particular newly imported table. So whatever the LTS that is having here, this LTS is joined. Okay, this LTS contains only the address of D1 calendar. Now the moment whenever we drag and drop any of these particular columns into any of these columns, then a new address will get created for these months, and this particular thing will get mapped through that new LTS. Okay, let us see how it happens. Okay, while I am explaining this importing multiple tables, I have shown that clearly whether how this LTS is going to come. Whenever okay, even though when you drop this year onto this particular source itself, okay, it will just create one more LTS for this particular thing. Why? Because it's not having address of this particular table, so it won't get routed to this particular thing. But if you dynamically drop this year onto this LTS, then new address will get created for this particular table in LTS. That's how it happens. Okay, let me show the difference. If I drop it onto this LTS, even it won't allow to drop it onto LTS even. Why? Because it's not having a direct join relationship between them. So what I'm going to do now is I just want to drop this. I can drop it over here onto column, okay, which is going to create one new LTS for this, or else I can even drop it onto this table itself. You can do anything, but while dragging and dropping, you just play safe. Why? Because if the names are same, this year and year, it can treat it as same. But we have, if it is something like this year, month in year, we have underscore over here, and it's very difficult for the tool to understand that this column and this this column both are same, so it's going to create a separate one more column additionally, which may cause some duplication. So the best practice is to just drag and drop it onto the same column where it's mapping. Now see, new months LTS has been created over here. This given underscore calendar, okay, just click on this column tab. Here year is coming through given underscore calendar physical table, but in this LTS year it's coming from this months. Okay, we are going to map the remaining other columns over here even. And coming to this Yago, we don't have quarter description, so just ignore this. We have quarter, drag and drop it onto the quarter. Here quarter is calculated column, so calculated column won't appear there on that LTS. Okay, let me show that to you. Double click on this quarter. See now, from physically it's mapping to this months, and but whereas here in the corresponding scenario it's mapping to some other table using this existing formula. I have mapped this quarter even. This month name is nothing but month over here. This month code is nothing but we do have some month code over here. Month code. This month in year is equal to this month in year. This Mago is equal to Mago. Now we have mapped all the columns, but here we have different levels, right? In these months we have details up to only this month level. Okay, under this month level we don't have data. Under this month level the data will be available through this LTS. So we need to provide some guidance to the tool to which LTS it needs to refer to the particular level. Okay, how we can do this is just double click on that LTS and click on this content tab. Here the content we already have some last level to day level. That's okay. But whereas here on content tab we have data only up to month. So we have provided month over here. That's what. Okay. Okay, let us do the same operation for the remaining set of things even. And coming to this customers, we have imported this D1 sales rep table. Map this sales rep to this sales rep. This SSN is not available over here, so ignore that. Map region to region as well as district to district. Now this new LTS got created, and here we have details up to sales rep. So just select sales rep and click on OK. Okay, it's everything is cool up to here. But coming to these products, we have already used this D1 underscore product type over here. We used it in a way like this products is joined to subtype and subtype is joined to this product type. Okay, as there is direct join, we have routed it through this products LTS. Now I just want to delete that relationship and I want to route this separately. Okay, in order to do that, what I am going to do is just double click on this and click on general. Here I am going to delete this particular reference for this. Okay, whenever I delete this particular reference, this item type will lose its reference. Why? Because the address is not there in this particular LTS. See, the moment I delete this, it will become empty. That's cool. Now let's start doing our operations now. Here item type is empty over here. Now I am mapping my type code to this type code. The moment I drag and drop on this, new LTS got created for this, and I am dragging this item type onto item type. Double click on this, check whether the two columns are mapped perfectly here or not. See, now the two columns got mapped perfectly over here. And click on this content tab. Here I have detail up to only this type level. and click on OK. Excuse me. Now go to this fact. The aggregate fact that we have imported over here is this D1 order AGG1. What we need to do over here is, even here I need to map all these columns. Here this ACTL ASTND is nothing but dollars over here. Just map. Just expand this sources button. I'm going to map this ACTL ASTND to dollars. Now CM dollars to CM dollars. DWA cost extend to DWA cost extend. Net weight ship put to net weight ship. Period key. This. Okay. This period key is not available over there. Okay, let me drag it on to this period key. Rep cost index to rep cost index. Rep key is not available over here, as well as this type key is not available. Units order to units order, and unit ship to unit ship. And here for this we need to define levels. Here in customers we have details up to the least level of detail, that is we have granularity up to sales rep level. In products the granularity is up to type only, and in time we have up to month. And click on OK. Now here, okay, in presentation layer we are not going to disturb anything because everything is perfect over there, and we have not added any new columns even. So there is nothing to add into this presentation. But coming after the query is hitting this BMM layer, we are going to route the query. Like if it is hitting up to this level, then just route this through this LTS, or else just route it to this LTS. That is what the changes that we have done now. Now let me click on check-in changes. Here we are going to get some errors now. Here it's saying as calendar level is functionally dependent upon level month, but is more detailed. Okay, this 15019 error will come. Why? Because while dragging and dropping we have imported some keys onto this thing. Okay, we have imported some keys onto the table here, and new keys will also get created over here as we are going to drag and drop. Now we need to delete unnecessary keys on logical tables. Here I am going to delete this months key. Yes, click on OK. And here I am going to delete this sales rep key. Click on OK. And here I need to delete this product type code key. Come OK. Just check whether we do have, okay, we don't have any extra keys got created over here. Everything is fine up to now. Now let me check in changes now. This is the problem that got created. Okay, usually this error, okay, what this error is saying is this dimensional table source calendar months has an aggregate content specification. Okay, this months has only granularity up to month level. This is fine, but the source mapping contains some column mago with a functional dependency associated with the level. Okay, the error is not giving us the perfect information over here, but we used to get some kind of creepy errors like this. But the actual problem behind this error is here in time. In here I have combined these two things, and that's creating a problem over here. Now what I'm going to do is I'm going to create one more let me revert something over here. Just click on this and let me add one more key. Main key, or else I want this key for display. I'm naming it as display key, and here I'm going to take the combination of two things, that is this day name as well as YYMMDD. and I am using this for display, and I don't want to use this for display, and I want to drive this entire thing using this D1 calendar key. It acts as a key, and this acts as the something that used for display. Now see, now this business model is consistent, and do you want to make it available for queries? Is this fine? Now everything is working perfectly. Now as per whatever the design that we have performed, as per whatever the operation that we have performed on it today, it's we are routing that up to month level. It needs to use that months table, that newly imported months table, and after that level we just want to import data from the other detailed table, that is this calendar table. Let's check. We have done all the configurations part over here. Now the next thing that we need to do is we need to check whether whatever the things that we have done is working perfectly or not. In order to check that, what we need to do is this entire thing we need to deploy into the server, and from there we need to check whether it's working perfectly or not. I have already deployed the same thing into the server already while testing. Instead of wasting time in deploying, I will just show you the output. Log into analytics page. You need to ensure yourself that this WebLogic user, this particular WebLogic user, that the log level is set to 1. Let me open this in online mode. Now I have opened entire thing in online mode. In order to set log level to 2, what we need to do is we just need to click on manage identity and go to this actions, set online user filter, provide star so that we can see all users available. Double click on this WebLogic user and here set log level to 2. So now if log level is set to 2, we can watch the logical query as well as the physical query that's going to hit the database. Now I'm going to generate a new report. Let's start testing from this time level. I'm going to generate a report from year as well as measures and dollars. Click on results. As this is the top level, then as per the configuration that we have done, it needs to hit the aggregate tables itself. Let's check whether it is hitting aggregate tables or not. Go to this administration tab, click on this manage sessions and click on view log. See here it's hitting D1 order AGG1 and months. Both these tables are aggregate tables only. This means that whatever the query that is generated is hitting this aggregate tables and all our operations are perfect. If you want to check this query directly, even using your SQL editor, even you can check this thing. Click on copy. While copying, we need to copy it from this with. This is the query that is going to hit the database. See how it's saying sending query to database. This is the physical query that is going to hit the database, and this is the logical query that's going to hit BMM layer. If you want to check this particular thing even, you can check it. It's going to generate the same results, but the column names would be different. Now let us check whether, okay, let us drill down the same report and check whether it's going to hit the detail table when we drill down to detail. Okay, I'm going to drill down this here. Now it's quarter, even quarter can be fetched from months table. Okay, I'm going to drill down months now. Okay, now I have drilled down months and I got this day name and years. Now let me check whether how the query got generated at the backend. On leave page. On manage sessions. Just open the last but one log. Click on view log. Now here C under from C. Now as I have drilled down, it's hitting D1 calendar 2 and D1 orders 2. These two are detailed level tables. Okay, by this, okay, we can get ourselves confirmed that they are going to hit. Okay, they are hitting the detail level tables as we have drilled down to detail. Okay, that is how we are going to improve the performance of OBI server. If the company have given you some project, you have just jumped into the project and you started working on whatever the tables that they have provided. Okay, you have done everything well and you have deployed it into the production. But during our development phase, we will be giving with some test data, and the test data will be like limited data. And whenever everything deployment is done into the production, what happens is in production data will be huge. Then the issues start coming up for us because we will be getting some kind of a box like whenever I'm going to generate some particular XYZ report, it's taking more than some kind of 4 to 5 minutes. Okay, which is very pathetic for the customer to wait. So then we need to start working on performance activities like this. Okay, this aggregate tables concept is one of the concept that we are going to use to improve the performance. This is one concept, and we do have one more concept like the same thing called like this aggregation. Okay, this aggregate tables concept, it deals with, okay, it's going to save time while doing calculations. This is all about this aggregation concept. And we do have another concept for improving the performance of OBI and to fetch results faster. The one more concept that is available is partitions and fragments. Partitions and fragments is nothing but, okay, let me put it as this. Partitions and fragments is nothing but, let me open this chord table. Here we have created some tables called as aggregate tables. Okay, by using that aggregate tables, we can save a little time in, okay, that is consumed during calculations. That is the use of aggregate tables. And coming to the other set of tables, okay, that we have one more concept that is called as partitions and fragments. This partitions and fragments is a concept where here what we are going to do is, even here we are going to create some new tables, but here we are going to create tables in such a way that if the names are between A to M, okay, I'm going to divide this particular individual table into two tables. I'm going to divide this table into two tables, means two partitions. Okay, each and every individual partition we can call them as a fragment even. Okay, one partition contains data from A to M. Another partition contains M to Z. Or else we can take it like A to D one partition and D to H as one partition. We can create tables with multiple partitions. After creating tables with multiple partitions, then okay, we need to do our job like importing that particular tables and doing configurations as if like what we have done for this particular aggregate tables. Okay, we need to do some same kind of operations, but we need to write some conditions over there. If the data of the query is having data that is less than this particular D, then go and hit this particular table partition 1. If it is greater than D and between H, go and hit the partition 2. If it is between so and so, just hit the other partition. Okay, we need to provide such conditions. Based depending upon the condition, it's going to hit the particular partition directly instead of searching the whole millions of records. Okay, the tool it will get automatically routed to the detail level table in which it's going to fall. So lot of time will get saved over here. Instead of searching all the records, it's going to the particular set of records and it's going to hit that particular table, which saves lot of time for us. Okay, that concept is called as partitions and fragments. And here this partitioning, we are going to do this partitioning in okay, we are going to do various types of partitioning over here. The partitioning will be based on this fact based partition is nothing but depending upon facts, and value based partitioning. Okay, depending upon the level, we are going to do some kind of level based partitioning, and we do have some other types of partitioning like complex partitioning. We have various types of partitioning that can be implemented. Okay, in the next class, we are going to discuss in detail about how we can work on these partitions and fragments to improve performance of OBA or Oracle BI server. Okay, that's all for today. Thank you.